We are BIMOVIS, a small structure determination company that combines high-resolution structure determination, so X-ray crystallography, cryo-EM and cryo-ET, with high-end visualizations and training of all the methods we provide. So in our lab we use the Refeyn TwoMP. This mass photometer analyzes a weight range from 30 kilodalton to about 5 megadalton, which is in most cases sufficient for all the samples that come into our lab. Basically, the device looks at single molecules. It pretty much sees single particles landing on the glass slide, and by counting them and analyzing how big they are, it just gives you a direct readout on what's in your sample. Mass photometry for us is a very valuable method to analyze the sample as soon as it comes in. So basically we can do an initial check of the quality of the sample. The second experiment is more complex. Here we want to form a protein complex of 2 or more components, which we first have to put together and then purify via size exclusion chromatography. In this attempt, it is very handy to have first an initial checkup of the single components, and then after the run be able to again quickly determine the composition of the complex peak that we just purified. It is just another layer of safety that is very quick to apply immediately before we go into the final methods of determining the structure. You see, all of our structure determination methods rely in one form or the other on averaging the signal of millions of separate particles. So if we have impure samples, be it various conformations or even other protein impurities, then our primary issue is that this, for one method, introduces noise. For the other method, it might completely fail us, since in crystallization, an inhomogeneous sample might fail to ever crystallize properly and therefore stop us in our tracks. One reason for it is that it is fast. So if you have a proper warm-up time planned into your day, you can just within about 5 minutes find out what your sample consists of. The second advantage is sample amount. So for even an analytical size exclusion column, I will have to inject at least 5 to 20 times the amount I would have to use on the TwoMP. And third is that the precision actually is better. My usual workflow starts with warming up the TwoMP, after which I prepare buffers, ice buckets, sample, and whatever else is needed for the current experiment. And then the first lab work usually consists of analyzing the sample as it was freshly thawed with the TwoMP. If it already looks homogeneous enough, then I can immediately continue with my other experiments. So in my case, that's typically directly preparing the cryo-EM grids. If the sample doesn't look good on the TwoMP, this is the point where we start purifying it in another step using size exclusion chromatography, after which again I like to analyze the single peaks that came out of the column with the TwoMP due to its higher precision. Hands-on time on the TwoMP is amazingly fast. You have to warm it up, meaning that you have to be there about an hour before you want to start your experiments, but if you plan that in, the actual time that you have to deal with the device while you're handling your protein sample is about 5 minutes before you have a proper answer of how good your sample looks like. We had a lot of protein samples already in-house, and from day onwards we had no big issue in measuring any of those samples. The principle is quite clear, and if you take care of the 3 or 4 important things during each measurement, then you get very decent results very easily. The team at Refeyn was a huge help. We had a lot of questions regarding different targets and how far we can stretch the device in terms of different samples. And on top of that being answered quite quickly and with a lot of profound knowledge, they also do a lot of research themselves still. So there is still a lot of interest in the company on how the device can be applied to different fields, to other weird samples, and I really like that. There is one specific example I had here in our lab. This was a complexation experiment, and I already used the TwoMP to get a rough idea on the binding ratios to put on the size exclusion column, and the column resulted in 2 separate peaks. What I did was to run both of these peaks again through the Mass Photometer, and as expected, the complex peak was homogeneous and fine to use. But the second peak, in truth, wasn't a single peak, but a rare incident where multiple peaks just perfectly aligned with each other, basically like the fingers of a hand, that you could draw an entire Gaussian curve over all of them together and get a homogeneous peak back out of it. So if I had only the size exclusion at hand, I would have expected this peak to be perfectly fine and pure. And in our case, we knew that this would not be of any use in structure determination. Yes, that was my PhD project. My neighboring group had a device already years ago, and I used it to analyze my membrane protein. We had a bit of an issue there that it did crystallize surprisingly well. However, we only ever got the partial structure out of it. And there was a big debate on whether or not the protein was fragmenting before it crystallized. So normally, if you have very small crystals, you don't have enough material to look at them properly in an SDS page, especially if you want to see a small fragment. And in this case, I could take the tiniest crystal, dissolve it, put it back into the mass photometer and prove that while we are missing something of the structure, the protein in the crystal is fully intact. So that is really nice to find out. There are 2 applications. One is a technical add-on for the mass photometer, which is called mass fluidics. This one allows us to basically see the composition of any protein sampled as it was at micromolar range while being measured at the nanomolar range. This becomes especially relevant if you imagine weak binding complexes, so for example an antibody that is still in development, or intrinsically weak binding components, for example of a human signaling cascade. The second application is a software. It uses the readout of a normal mass photometer, but it allows us to much faster and much more precisely analyze the composition and degradation states of an antibody sample. So if you deal with larger quantities of samples for analytical reasons, then this one is also really interesting.